Hey class. So, as we've been learning more about population ecology and ecosystems. Today we're going to be talking a little bit more about energy within an ecosystem. So, for the first few minutes of class, we're going to have an activity with these bags. If you want to pass them around. Now, what I want you guys to do is I want you guys to place them on your hand, not over your head, not tightly over someone else's head, not tightly on your arm so that you cut off circulation, but I want you to wrap it tight enough to where your hand is kind of trapped in there. Yeah, kind of like Adana has it.
Yeah.
All right? Wow. Do you need help, Taylor? Are you doing okay? You need help?
Got it.
Okay. And then we're just going to wait 3 minutes.
In
That's
silence?
it. No, we can talk. Do you guys have any thoughts as to why we would be doing this?
No.
Why would this be related to energy? Does your hand feel anything?
I mean, my
as it's
hand
in
feels
the bag?
kind of warm.
Warm?
Yeah.
Heat is a source of energy.
Heat is a source of energy. Yeah. Anything else other than warm?
Wet.
Not right now.
Feel some moisture.
Moisture.
Yes.
Why are you going through like that?
I'm just listening to you guys.
Does that mean we're on the right track?
Maybe. Maybe not. What else are you thinking?
Kind of uncomfortable.
Yeah? Like uncomfortable because it's hot?
Yeah.
Yeah. How does it compare to your other hand? Is your other hand
My other hand-
sweating too?
No, it feels cold now
Yeah,
because
it's
this one's
clammy.
hot.
Yeah?
Clammy here.
Mine's not.
I
like it. My
too.
hand feels clammy now. Go home.
Yeah.
That's what mine's cold. Cool as a cucumber.
Well, that's a cucumber. Yeah.
Enjoy its freedom.
Yeah. Well, I think those 3 minutes are up. Or at least you've had enough time to delve into it. You can take it off now. Now tell me how it feels.
Cold.
Amazing.
Cold. So you guys described it as warm and wet.
Yeah.
Did you say that your hands were sweating in the bag?
Overall.
It was on the verge.
Yeah.
On the verge of this,
Why do you think that is?
Because we're hot.
Yeah, but why?
Because the air was trapped.
Yes. Yes, you could say that.
Your hand is a source of heat, and it's
Your hand is a source of heat, a source of energy.
yeah.
Now, would you say that that energy was lost or gained?
Lost.
Lost?
Yeah.
Yeah, I'd say so too. Yeah, so in that activity, when your hand was in the bag, energy was lost from the hand, and that's why your hand was sweating. Can we think about any other times in life where we talk about energy lost or gained?
When you're exercising.
Exercising, yeah, you also sweat.
Eat food.
Eat
Gives you
food,
energy.
yeah,
Makes you feel good.
it does. We're actually going to be talking more about that in a second. Eating food. Animals eat other animals, they gain each other's energy. That's what we're going to be talking about today, energy transfer in the ecosystem. But it may not be as efficient as you may think, which is what this video is going to tell you. I want you to pay attention to this video. I will be pausing it before a very important moment. But enjoy. No, wrong one. I'm the classic teacher with technology problems.
The wrong button.
It's that time of year again, the time when fear leaves the ocean and heads into your living room. Nature's deadliest killing machines, as you've never seen them before. It's Shark Month, and this time, it's personal.
I don't think you have anything to worry about. Some of that footage seemed a little fake. Dear Tim and Moby, what is an energy pyramid? Your friend, Nicole. I don't think she means that pyramid. The energy pyramid is a model for how energy spreads through an ecosystem. You remember food chains, right? Why are you being so literal today? Okay, the food chain describes how organisms in an ecosystem are linked together by what they eat. At the bottom are producers. On land, that includes plants from moss and grass to shrubs and trees. The producers are eaten by primary consumers. These are herbivores, or plant eaters. In turn, the primary consumers are eaten by secondary consumers. These are carnivores, or meat eaters. This continues until you reach the animals at the top of the food chain, which have no natural enemies. Sharks are at the top of the marine food chain. Bears might be a better example here. Meanwhile, decomposers like bacteria and fungi break down dead animal and plant matter. This recycles nutrients back into the ecosystem. Food chains usually combine to form food webs made of many interconnected and overlapping chains. But let's back up for a sec and ask why animals eat in the first place. Well, yes, leaves, grasshoppers, and snakes are delicious in certain cultures, I guess. But that's not it. Animals eat to gain energy. It all starts with producers. They create all of the usable energy in an ecosystem. That's why they're called producers. Through the process of photosynthesis, they convert the sun's light energy into chemical energy, specifically a simple sugar called glucose. Glucose is the fuel that drives all living organisms.
You guys
Plants
remember
use
this?
up most of the glucose they make to grow and reproduce, but they store a little bit of it in their bodies. So when a rabbit eats a plant, he's only getting a small fraction of the energy the plant got from the sun. The rabbit, in turn, uses up most of that energy to do things like breathe, keep warm, move around, and make baby rabbits. So if a fox comes along and eats that rabbit, he's only getting a teeny tiny fraction of the energy that was first absorbed by the plants. Get it? Right. All of the energy in an ecosystem ultimately comes from the sun. And since the amount of energy decreases as it travels up the food chain, it can be represented as a pyramid. In general, each level of the pyramid gets 10 times less energy than the level below it. So, let's say you've got
I want to go back to that
each
pyramid
level of the
thing.
pyramid gets 10 times less energy than...
But this is what we're going to be talking about today. So, just as when your hand was in that bag and energy was lost, throughout the various levels, from producers all the way to the top predator, energy is lost in that ecosystem as well. And it's actually a rule called the 10% rule. So if you look at these numbers, the producers start out with 10,000 joules of energy, and 10% of that moves on to the herbivores for 1,000, 10% to 100, 10% to 10. Make sense? We're going to be learning about that more in depth today.
and the level below it. So let's say you've got a square meter of forest. Every year, the plants growing in that little patch produce 10,000 calories. That's a unit of energy. Now, let's say herbivores consume those 10,000 calories. They burn 9,000 calories and store 1,000 in their bodies. So, for their predators, that square meter of forest produces only 1,000 calories of energy per year. That means there are going to be way fewer snakes and raccoons than rabbits and grasshoppers. See where this is going? Right, if the carnivores eat all of the primary consumers, they'll gain 1,000 calories of energy. They'll use up 900 calories and store 100 in their bodies. So, for the top predators, that square meter of forest only yields 100 calories per year. Oh, come on, sharks aren't part of the equation here. That's better. Anyway, since the bears and hawks have a fairly limited number of calories to live on, the ecosystem just can't support that many of them. So, in most cases, as energy decreases up the food chain, so does biomass, the combined mass of all the organisms. A small meadow might support 10,000 grasshoppers, 100 snakes, and only 1 or 2 hawks. Great, now let's get back to Shark Month. I think there's a special coming up about a shark who lent out money at a very high interest. Huh, who could that be? You know, there was something fishy about that guy.
Alright, you know you love those puns, but go ahead and get out your notes and we're going to start taking some notes on that 10% rule.